Section 7.1 Day 1 is titled Exponential Functions, and today we are going to learn the next in the whole line of memorized functions. At the start of the course, we started to say, there's many important things to memorize. I just showed you 3, 4, then you take like the graphs of sine, cosine, and tangent. Those are all critical graphs that if you ever want to move up in your study, you need to understand what they look like. Now, today we're going to learn what an exponential graph looks like, and it is just as important as any of the previous graphs that you guys have looked at. They would be in kind of the top 10 of memorize this, they will pay dividends, even if you have access to technology like a graphic calculator. So here's how we're going to begin. In the PDF notes, it just starts off saying an exponential function is in the form y equals or f of x equals c to the power x. So two things. First of all, notice that the x, the variable, is the power. That's what makes it an exponential function. Now, c is any real number. C could be the number 2, and we'll go back to that. C could be the number 12. C could be the number 7. C could be 7.1. It's any number. It can even be a decimal number. It's just any real number. I'll just go back to a 2. Now, it doesn't matter what that number is. The basic shape always remains the same. And in the end, we'll talk about if it was a 7 or a 12, what that would do, what would be the subtle difference. So this is what I want you guys to memorize. The graph of any exponential function in this form, where this value 2, so c is greater than 1, is going to go as follows. Okay? It is called an increasing function. And let me just give you guys a description of it. First of all, what happens is if you go backwards, even though you don't graph backwards, what it does is it goes forever to negative infinity on the x-axis. It never ever touches or crosses the x-axis. It's a horizontal asymptote. So what would you say the range is? Y is always greater than or equal to a value of 0 and, not equal, because it's an asymptote. It never touches it. It doesn't cross it. What does it do on this side if you were working this way? It does go up forever, but it does not go straight vertical. It keeps going up and over, up and over, up and over, very high. So it does go forever on the x-axis. So then what would be the range? It is all real numbers. It goes forever backwards and forever this way, even though it creeps going up and up and up and up. The x-intercept, again, it's not equal to 0. There isn't one. And when we move into doing the shifts of the graphs, well, then we can play around with the x-intercept. What would be the y-intercept? Right now, that is just a height of 1. And this is the basic graph. Even if, again, I said this is 22 to the power x, even though there's a few subtle differences, the overall picture is basically there. Now, for number 2 in the notes, how could you possibly prove this? Okay, so the proof, and I'll just do 2a, and then you guys can look at B because it's the same thing, just backwards. You could prove what y equals 2 to the power x looks like with a good old table of values. Now, this should look familiar. We've been doing this for a long time. It was the old -2, -1, 0, 1, 2. We did it in a higher end version when we'd graph trig. We could even move it up to -3 and then +3. And what you could do is you could actually plot a set of points to see what this graph looks like. Now, how would you begin? Maybe let's just start in the middle at 0. It's okay to do that. Imagine you took 0 and you put it right where x is. So you would have y is equal to 2 to the power 0. And you ask yourself the old question, what is anything to the power 0? Well, it's a height of 1. And so you have a plottable point. Let's say you then took 1 and put it in for x. So 2 to the power 1 is just 2. So what you're saying is when x is 1, the y value is a height of 2. Then you put in a square, and 2 squared is a 4, so then you're getting a height of 4, and you start to kind of see that shape creeping up. The next value would be a 9, so it goes pretty high. I don't even have enough whiteboard left. Let's work backwards. Let's say you put in -1. What would you be getting when you get a -1? Well, here's where your work from previous math courses pays off. Anytime you see a negative power, think flip. This really means 1 over 2 to the power 1 or 1 over 2. So what we're saying is at -1 on the x-axis, you got a height of a half. Now here's where you kind of see the shape appearing, and we don't need to keep the pattern going. let's say we put in a -2. You see a negative power, think flip. 1 over 2 squared is 1 over 4. So at -2, now we're down to a height of 1/4. And then one more probably should be enough. If we put in the x value of -3, we get 1 over 2 cubed. 2 cubed is 8. So at -3, we see a height of an 8. So we went from a half to a fourth to an eighth. And now what you do is you see the shape coming. If you went to -4, -5, -6 on the x-axis, it just keeps getting a smaller and smaller fraction. That is why the graph comes down and it approaches the x-axis like a horizontal asymptote. Now, this right here, this graph, would be one of the ones that you guys commit to memory. One of the, I call it the top 10. Now, if this is number 7A in terms of committed to memory, 7B is the one in the PDF notes that is right beside it. Let's say you guys had a fraction. So something that is less than 1, and it would be between -1 and 1. This guy right here, as the chart proves, just does something in the opposite. Because of the fraction and the flip, the graph actually just mimics what happened before, but it's like a flip over. Everything else remains the same. It just approaches like an asymptote on the positive x-axis, goes this way. Every value would be the same. The domain is all real numbers. The range is greater than 0. Y-intercept is 1. X-intercept is none. Nothing else changes. Probably you'd have this one as kind of a 7B in your memorize, and the chart confirms it. Now, the end of your day in the PDF notes, it would be letter 2C, and I'm going to erase just to give a bit more room, is where you kind of say, all right, so what are the subtle differences? So let's say that you had just y equals 2 to the power x. Well, y equals 2 to the power x comes up through 1 and then creeps over and over and over and up. Okay, so again, this would be y is equal to 2 to the power x. Well, let's say you had one like this. Let's say you guys had y is equal to 5 to the power x. What would simply happen? Okay, it follows the same shape, but then starting here, it would actually go steeper. Imagine you were at 1 on the x-axis. Well, if you put a 1 there, then you're at a height of 5. If you were at 2 on the x-axis, well, then you'd be at a height of 25. What it simply does, the bigger the number is there, the steeper it goes. If you had y equals 7 to the power x, well, it would go even steeper. It just changes the slope. Over here, the fraction would get lower quicker. Instead of it being at a height of a half, well, then it would be at a height of a fifth. So it would go quicker towards the asymptote. It still doesn't cross it. That's what it would look like. Now, I'm not sure if this is the first time you've ever seen it. I'm going to introduce a very, very important one, and it is going to be y equals e to the power x. If you don't ever take a calculus-based course, you will never know why e to the power x is so important. If you do take a calculus course, you will realize it is the critical exponential function. It is the most important one, way more important than any other random number. So what is e? It is a certain number that I never remember all the digits. It's very similar to pi. E is 2.718, and then it keeps going forever. It never repeats itself. A mathematician by the name of Euler, okay, and I think I might even know how to spell it. I usually call it Euler just to make the people in French mad. It's called Euler. Euler's number is a critical number in calculus, and it is simply 2.718. The graph would just be in between, because that would be in between the 2 and the 5. Don't freak out. Nothing really to worry about here. You're just trying to know the general idea. The bigger the number is, the steeper it goes. And I just wanted to introduce you, possibly for the first time, to what Euler's number is.